Okay, I hope it is sharing. Okay, guys, a very warm welcome to my lesson for today, where we are going to be looking at physical sciences, mainly a revision. It's what we're going to be doing. And the most important topic that we're going to be looking at, it is this one of Newton's laws. I've got a very nice question there that I would like for us to quickly have a look at. Maybe let me do this, just stop the rotating. Okay, so this is what I'm having, which I would like for us to very quickly go through, and you guys are going to be working on it in my presence. As you work on it and you struggle, you let me know, then I will guide you accordingly. So question number 3.1, it says, state Newton's law. State Newton's second law of motion in words. I'm assuming that by now we all know how to state Newton's second law of motion in words. Remember, such a question, it just comes. You'll never know when it comes, but that means before you go to an exam, you just need to make sure that you know how to answer this question. Otherwise, if not, it's going to be a big problem because it's not something that we can teach. You just need to read that and know it by heart. Okay, it looks like we might be jumping on to 3.2. It's fine even if you are in a position where you want to state that in the comment section. But before we go deep, let me quickly check. Are we all okay, honorable members? Can you clearly hear me? Can you see on my screen?
Yes, sir.
And also,
Yes, sir.
Yes, sir.
are we all able to state Newton's second law?
Yes, sir. Yes, sir.
Yes, sir.
Okay. Then it's fine. So now let's have a look at the next question. The next question reads as follows, 3.2. The diagram below shows two blocks, as we can see, each of mass 8 kg and 12 kg respectively, joined by an inelastic string of negligible mass. Okay, the string runs over a frictionless pulley. The 12 kg block is on a rough horizontal surface, while the 8 kg block is suspended as shown in the diagram below. You just need to be very careful, especially when you have to do your calculations regarding the 12 kg, because they said it is on a rough surface. So what I usually do when they say it is on a rough surface, then immediately with a pencil, I just do that. Just to remind me that it is a rough surface, because otherwise, if not, you will then have to draw a labeled free body diagram and miss some of the important forces. Okay, then it's fine. I think what we are seeing there on the diagram, it is explained in the statement, even though additional information is that the 12 kg is on a rough horizontal surface, which I had to do that in yellow to remind me of that statement. So now they say both the 12 kg and 8 kg blocks move with a constant velocity. This statement alone, honorable members, very much important. Can anyone tell me what does it mean when they say they both move at constant velocity? Indirectly, what does it mean? Anyone who can tell me?
Sir?
Yes.
Doesn't it mean that if net equals to 0.
Wait, what did you say?
I said F net is equals to 0, sir.
F net is equals to 0. No. The formula says F net equals MA. So this formula, it doesn't change LV. So that means if you have to do calculations related to F net, or maybe calculating a force where F net is involved or whatever, you must first make sure to write that formula as it is, which says F net equals to MA. And then on your next step, that's when you can equate it to 0. But what I want to understand is that how do we end up getting the 0?
Sir,
What does that constant velocity ask? Yes, go for it.
Yes. When they say constant velocity, I think it means they saying acceleration will equal to 0, which will essentially make the whole formula equal to 0, because anything multiplied by 0 is 0.
Yes, 100%. 100%. So that is the explanation that I wanted. Of course, F net will be equals to 0, but you must just remember that the formula for calculating acceleration, it says V final, V initial over change in time. That is a change in V over change in time. So when the velocity is constant, it means V initial, if it is 100, let's say, meters per second, even V final will be that same 100 meters per second. So it's like you have 100 minus 100 divided by whatever the time. As long as at the top we have 0, it doesn't matter what we have at the bottom. It will end up being 0. So that's where now our acceleration is a 0. So that means you will have m into 0, which is our F net. So that means our F net, that times that, it will be 0. So that means the honorable member there had to make use of the word essentially, which means essentially with our acceleration being 0, then our F net will be a 0, which is what Henry was saying there. But most importantly, just make sure that you write that formula where necessary, because a mark is allocated to the correct formula. So now 3.2.1, it says draw a labeled free body diagram to show all the forces that act on the 8 kg. So quickly draw those forces. As soon as you are done, you take a photo and then you send it via the chat box. You don't send it via WhatsApp inbox, but you send it via the chat box. So what you will do, you just go in the comment section. You see, for me, it's a plus there. I just click, you see there next to where I'm supposed to tap. Next to that, it's a plus. So on your site, you must also find that. You click on that plus. As soon as you click it, maybe it will want you to attach something. You see there, photos or file. So once you take a photo, you will get it in the photos. Did you guys understand how to submit in today's lesson? Ningizwile nonke?
Yes, sir.
Yes, sir.
Yes, sir.
Is goodest. So the first few to comment, remember, we don't waste much of our time. We continue. And so let's see. Let me go back to the question so that you can see. So this, okay, 3 minutes. A maximum of 3 minutes is what you have. Then we move on to the next question. I do want to help you, but to a limited extent, so that you can try, think about it, and apply your understanding, get it wrong, and then correct it from there. But there are some basics that we just need to make sure that we clarify before we go deep. Just like that one says, being constant, we need to all understand what it means when the velocity is constant. And then, okay, I'll give you some time to work on it. Not say much. The moment, okay, no, it's fine. I will check at 20, 8. Okay. Let's see. I hope you guys had enough time. Okay, only 2 comments. What's happening? Let me download and see. On the 12 kg, wait, okay, on the 8 kg, we have that, and then we have that. Okay, this looks convincing. And let's see for Liseko. And that, yes. I am in agreement with those 2 labeled free body diagrams. I am in agreement with those because on the 8 kg we have that, and we will always have this one going down, which will be FG. And then we cannot have tension because the 8 kg is not in contact with the surface. But we do have that one being the tension by the string. Okay, so now 3.2.2 it says by means of a calculation, show that the tension in the string that joins the two blocks together is that being 7.8.4. There's another question, honorable members, that you need to very quickly look into, quickly work it out and submit. I saw something there. Okay. 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 Henry, I did notice that you've worked it out. Your working is correct. Or maybe let me say yes, that is the way to go about it. But what I want to
It wasn't me, sir.
quickly take you guys through is by the yes, Henry, are you saying something there?
It wasn't me. I wasn't the one who worked out, who sent that image, sir.
Who sent it? Can you just check for me? Or was it Serene? I think it was Serene. I don't know why I confuse you with Serene. Serene, was it you?
Yes, sir.
Okay, then it's fine. So just make sure not to work it ahead, because the moment you do that, others will just look into your answers and then they do copy and paste, or yeah, so we just have to do it question by question. So what I want to now do is to show you how you work it out by means of that formula which says F net equals 2MA. So the F net, it is your tension which is going up being positive, and then we can say plus our force by gravity is going down, it's in the opposite direction, equals MA. So it's like we have tension minus our F G, which is G being equals to the mass. We know that the mass is that of the 8 kg. The acceleration is 0 because velocity is constant. Maybe let's trade it. Okay, then it's fine. So we still have our tension minus mass being that of the 8. We have 9.8, which is equals to 0. And then tension, you take that to the other side, it becomes positive 8 positive 8 times that, and then it does give you positive 78.40 Newton. Serine, so your answer, yes, it is correct. It is correct. I wanted to show you how you work it out by applying that formula. Does it make sense, Serine? And everyone
Yes, sir.
else. Any questions on that one, or is it clear for everyone?
Sir,
Yes, what is the question?
why did we use the 8 kgs?
Which question are we on? By means of a shoulder, the tension in
It's
the
still on
string.
3.2.2, sir.
Okay, then it makes sense. Your question makes sense. A very good question, by the way, Ray, because it is questionable to say, why did we not use that one and we used that one? So everything that has to do with the tension, Ray, you will definitely need to cut that somewhere there. So when you cut it, it means you've got an option to use the 8 kg or the 12 kg, because the tension here, it is the same as the tension there. The only difference is the direction. You'll find that the tension there is working in that direction of up, but there it's working in that direction of towards the right. So we chose to use the one for the 8 kg because that one for the 8 kg, we don't need too much information on that one. We just have the FG, and we also have the tension going up. And by also looking at the marks, you can see it's not supposed to be a lengthy calculation, which means you can still try use the one for the 12 kg. You will still arrive at that answer, but that one for the 12 kg, you're going to have a long calculation because there's a lot that needs to be calculated there. You probably have that tension, you have another force, you have other forces, and you need to then make use of other forces to find something else, and all of that. That's why you have two options. Out of those two options, you go with the easier one. I'm not sure if you are answered a Ray.
Understand, sir?
Makes sense. Okay. Another question, honorable members. Anyone with a question? Ngasabi, Bandla kaNkulunkulu, a very important topic, this one.
Sir,
Yes.
sir, can I ask something, sir? But then, wouldn't we not be able to use the 12 kg one because the mass like kind of determines the tension, and if we calculate the tension on the 12 kg, it's not the same as the one on the 8 kg, because the mass I got for the 12 kg is
Wait, you are breaking
117.
Anna's world. Wait, you are breaking the one. I want to understand something. What are you saying? Are you asking or are you saying we wouldn't use the 12 kg because we don't have enough information? Or what is your comment there?
No, sir. My question is, wouldn't we not be able to use the 12 kg as it wouldn't take us to the same tension that was given to us in a way?
I see. No. The tension is the same. So you see the tension that we got by using the 8 kg, which is that tension. It is the
Yes.
same tension as that one. So the tension experienced by the 12 kg cannot be different from the tension experienced by the 8 kg. Actually, the tension is the pain which is being felt by the string. That is the tension.
Yes.
So can you see, even if we cut it there, the pain experienced there, it is the same pain experience on that other side of the cut. So what I'm saying is, even if we had to use the 12 kg, we were still going to get that answer. It's just that with the 12 kgs, when it was going to be a complicated question or calculation, yes, that's what I meant to say. It was going to be a complicated, long calculation. And when you look at the marks, it doesn't worth it. So that means chances are high that you need to carefully choose between that and that. And this one seems to be the easier one to go with,
Okay, sir. Thank you, sir.
because it's only two forces. And the other thing that guides you in terms of you using that one is because already we have drawn a labeled free body diagram. So on this topic, it's in most cases where they want you to first draw a labeled free body diagram, and then only after they want you to calculate with calculations related to your labeled free body diagram. So you will see in most question papers, they wouldn't just say calculate this, but in most cases they will want you to first start with a labeled free body diagram. I'm not sure if you answered there as well.
Yes, sir. Thank you.
Yes.
Yes.
So through your questions, honorable members, it makes it very much easier to expand on my explanation, because that's how you learn some more. Yes. This answer is 100% correct. The one by Mendy there. Okay. So now we are about to move on to the next question. I think what I'm going to do now, maybe let me remove which information am I removing? I'll remove that. I'll remove that. Okay, let me just remove all that. I will rewrite. Okay, no, we have all that information. Okay, so now we are moving on to the next question, which says, draw a labeled free body diagram to show all the forces that act on the 12 kg block as it moves with a constant velocity. Yes, there is a question, honorable members. Very quickly, work it out and then post your answer in the comment section, and you will score yourself 4 marks for that question. Again, I will give you 3 marks. So that means at 23 past, you should all be done and posted your questions. Just post the question for this answer. Remember, don't answer the next question, only for this one. And there we say tension is, maybe let me just write it and say the tension is equals to yes, that is the tension. The tension is that value. So that means any question related to those two, if you're focusing on one of those, you just know that, okay, the tension is that, it could be that it is the direction that is different. So when you look at it, it's like the 12 kg is pulling the 8 kg, and it's like the 8 kg is pulling the 12 kg. So that is why the directions will be different. It's like both of them are trying to pull that string, and with pulling from both sides, the pain felt by that string is 78.40 newtons. Okay, let me say much as I'm waiting for my answer for 3.2.3. Let me see if I've got some answers. Okay, someone has sent something. That is meant on, okay. Let's see. Okay. I'll wait for some more. There's Lady. Let's see what Lady has done. Ladies done. Good. This answers they look convincing. Okay, I'll just be waiting for some more, but in looks like in 2 minutes we should be continuing. Okay, there's Anna's World. Okay. Yes, the one for Serine. I have seen it. She's that, and that. Okay. No. It looks like all of you are getting the same drawing, and that serves as an indication that this is how it should be. So obviously the one for the 12 kg, we are just going to have that dot there. We will definitely have this one going down, which is FG, and then we will have this one going up, which is a force normal. And then the one that is going in that direction, it is this one of the tension, and this one there, it is the one for the frictional force, or some may do that. Yes, that is how you would answer that question of 3.2.3. So now they say write down the magnitude of the net force acting on the 12 kg block. Can you guys see this type of questions? No one is saying calculate anything, so just leave the calculator alone. They are saying write down the magnitude of the net force acting on the 12 kg. So you need to write it down. What is the magnitude of that net force? Comment in the comment section with that.
Because
Is there someone saying something? No one is saying calculate anything, but just read that question carefully and understand what exactly are they talking about. Write down the magnitude of the net force acting on the 12 kg.
Sorry, sir.
Is it a question, or did you comment in the comment section?
Sir, would it be right if we said that F net is equal to 0, sir?
Okay, why are you guys saying F net equals to 0? Why are you guys saying 0? Is there anyone who can explain why are you saying 0?
So there's no acceleration.
It's no acceleration, 100%. That should be the simplest way of explaining. Let me also add on to that so that others are able to understand. So guys, you see, this question is allocated 1 mark. First thing first, it's allocated 1 mark. And what are they talking about? Ryan. They are talking about a net force. So that means what you should do is to say, what is the formula for net force? This is how the formula looks like. It says F net equals MA. So already we know that acceleration is 0, then you multiply by that, it ends up being 0. So that means F net is equals to 0 Newton. So those who thought of this one, you see that one, it's not F net, but it is the tension, which you calculated previously. But for this one, they are talking about F net, the net force acting on that. So that means the F net acting even on the 8 kg is 0. Yes, the F net acting on that is 0. Why? Because it is also moving at a constant velocity. So trust me, honorable members, when I say this topic it has a lot of questions which may be a bit confusing, but the only way to master this topic is to do as many questions as possible, because when we have to calculate work, there's no way you can be able to calculate work without you knowing these basics, because work, you just take your force, you multiply it by distance. That's it. That's what makes it work. But you must first understand the forces. And this topic, it does carry some marks on honorable member. Look at those marks, 20 marks. Very much important that you go to an exam after mastering this topic. I'm not sure, does it make sense, honorable members? Anyone with a question on your side?
No questions from my side, sir.
Guys, no question from Moano. I want to make sure this honorable member understands. I want to make sure, let me see what's happening there. No. I don't know why this honorable member does this, but Serene. No. Who is that honorable member that I'm to communicate with? Where is that comment? Okay, I don't see where that is. Okay. So now let's move on to define frictional force. Okay, there is a question where they want you to define a frictional force. But on this question, honorable members, it's something that you need to note down. You need to note it down and make sure that you know how to define frictional force, because if you don't, then you are in trouble, honorable member, because something like frictional force, we only tell you once, or we tell you where to find it, and then it remains your responsibility to make sure that you know it by heart. Because if you don't, it will come in an exam and you can't rely on your calculator to define frictional force. You will have to make sure that you define it. So now 3.2.6, okay, 3.2.6, they want you to calculate the coefficient of kinetic friction between the 12 kg block and the surface. There is a question that you need to work on. I will give you enough time to work on that one. Maybe let me give you 5 minutes to work on it. Serene, please, honorable member, do not jump onto other questions. Only limit your answer to the question that we are on. And I'll give you guys 5 minutes. So that means at, let's say at 2046, that's when you should submit. We are now on to 3.2.6. Yes, I just need an answer for that one only. Let's see what this one. Let's see. Okay, Mentloke noted. And the lesson has been recorded. And I will share. Recording. Okay, let me just mute myself in the meantime. and give you guys enough time to. Okay, let's see. Yes, my name has done the calculation. See about that. And we will see about that. Oh, I wanted to mute myself, okay? Let me quickly do that. Okay. Trust me when I say the answer for this one. It is what you guys got being 0.67. No unit. Anyone who did not understand how the guys got this answer, can you then let me know? While we are still on this question, is there anyone who does not understand how to calculate that one? Ingasabi, honorable members, in case if there's someone who does not understand, let me know. I will explain. So there's someone who does not understand.
Yes, sir.
Yes, sir.
Okay, then it's fine. Maybe one of you guys just remain unmuted so that I will explain to you while we have a discussion about it. And let me also remove that. Okay, I want to also remove that. Maybe I should also remove that. Okay, then it's fine. Can someone unmute themselves so that I explain to you while having a dialogue? Who can I talk to? Who requested for me to explain it? Guys, I want to explain it to someone. Let's say, okay, yes, Liseko, don't mute yourself so that I explain to you. So this is what happens, Liseko. You still remember, Mos, the free body diagram for the 12 kg. You remember, is this one going up being normal? We also have this one going down, which is FG, and then this one going towards the right being tension, and then this one, that direction being that. Do you agree there, Liseko?
Yes, sir.
Yes. So now, this is what happens, Liseko. The formula says that kinetic frictional force is equals to mu normal force. This is the formula to calculate the kinetic frictional force. Do you agree there, Liseko?
Yes, sir, I agree with the formula.
Yeah, so now the other formula says F net. Yes, F net equals to MA. So we have the tension, we can say tension towards the right minus that kinetic friction, it's equals to MA, and our MA is 0 there. And then we did calculate our tension, which was 78.40
Newton.
Yes. Then we take to the other side, it becomes what is it, positive that. Do you agree there, Liseko?
Yes, sir. So in other words, do we use both formulas?
What did you say there?
Do we use both formulas to calculate the coefficient? Both
Yes, we will
FK
be
is equal
forced
to...
because yes, because I think what we are actually looking for is this one, that mu. That is the coefficient. We are actually looking for the mu. It makes sense now. So that is why this formula, we will then change that formula and write it as mu that n. Can you see there, Liseko?
Yes, sir.
Yes, where are you going to get your n? Your n, you get it by saying Fnet, because this object is not moving up and down, so that means the up and down forces balanced. So that means this force that goes up being what is it? The normal force balances with the Fg. Or if I had to use this formula which says Fnet equals to Ma, considering the vertical forces. On the vertical forces, we have normal force going up minus Fg because it's going down equals to 0 because the object is not moving up or down, it's not accelerating up or down. And then your N ends up being equals to Fg. So that means N is equals to mg. Yeah, so that is why they no longer write N, but they write mg. So that means it becomes mg there. Mg. And we know what is the value of m, which is what? 12. And we know 12. The value of g is 8.
9,8.
So that's why they say that divided by that. And that's how they get the mu, which is that coefficient of a kinetic friction. Does it make sense?
So we said 78,40. Did you divide it by the answer of 12 times 9,8?
Yeah, so it's like you having 8, which is equals to 2x. You will divide both sides by 2 so that it cancels, and then your 4 is equals to your x. So that means we will divide both sides by that 12 and 9.8 just so that it will cancel, and then we just have our mu.
Okay,
which
sir.
is equals to 0.67. Yes. Can you see now, Sek?
Yes, sir.
Yes. But while you're still on the line, let me explain to you something very much important. This is the part where most of you guys get it wrong. You see, when you have to calculate that kinetic, the coefficient of kinetic friction, Liseko, it's all about knowing all the up and down forces. Let's say there was this force which was at an angle, maybe it was force applied, but it was at a certain angle. So that means we were going to have the component of that force, which is going to be force applied cos of that whatever angle. We were also going to have this one going up, which is the component of force applied sine angle. Yeah, percent. So that means now the formula changes. It's not like the formula for the coefficient of that or the formula for the friction is always like that. It's not necessarily always like, it depends on the situation. That means now you will then use this formula and see how many up and down forces are balancing. So that means the upward force, would you agree if I say we have the normal force going up, we also have force applied sine of an angle, then minus this one of Fg equals to 0. Do you agree there, Sek?
So the Fg is balancing both the normal force and the force applied sine of an angle.
Yes, it's balancing the component and also the normal,
The normal force.
Yeah. So that's what I'm saying. Now the formula changes, the one for the friction. It depends
Yes.
on the forces. That means you must consider all the up and down forces. The reason why I'm saying I'm balancing, even though this force is acting at an angle in that direction, it's not like this object is going in that direction, but it's going towards the right. Can you see
Yes.
there, Lise?
Yes.
Yeah, so with it acting in that angle, there is its component which is slightly pulling it up, and then the other one slightly pulling it towards the right.
What's the
So
right?
if this object is going towards the right,
Oh,
we know because this angle is applied at a certain angle, we have its component, just like when there is this object on an incline. We know that this force is always going down, but the object is not going down in that direction of the arrow. That is why we therefore use the components, which is that FG parallel, which is the one for
parallel.
a sine of that angle there. And then we also have that component, that one which is the FG perpendicular, which is the one for the cos of an angle, which is the one that balances with that normal force,
Normal
because
force.
yes, now we no longer include that one in the calculation, but we look at that one and that one of FG perpendicular. Otherwise, if again there was still another applied force at an angle, maybe let's call it angle alpha. You see, this one is a pushing force. Can you see
Yes.
that because it is a pushing force, that means its component is going to be in the downward direction. This one of force applied, sine of that alpha. Can you see? And then the other component, which is the horizontal, will be this one of F applied cos of alpha. So that means now, in terms of the up and down forces, you have the normal force, which is positive because it's going up. The component is now going down in this case, which is the force applied, a sine of an angle. Even F by G is going down, then you see this is equals to 0. And then you're just therefore going to make N the subject of the formula, which will be equals to Fg plus F applied a sine of an angle.
Sine of an angle.
Which is therefore what you're going to substitute there as your N. I'm not sure if I'm losing you there, Liseko.
No, sir. I think I understand.
Yeah, so you see, even on that one that we did the first time, that means on that one, the normal force, it is therefore going to be, you take those to the other side, then you end up having Fg as positive, minusing Fa sine of an angle. So you will be given applied force, the angle will be given, you just substitute. This one is mg, you just substitute. That's how you then substitute into your formula there being n. So maybe, Liseko, let's say the formula, it remains the same as Fk equals to mu n, but n is not like it is always equals to mg. It depends on all the up
scenario.
and down forces that you are having. It depends on the situation, whether you have a pulling or a pushing force at an angle, or whether you have other angles which may be acting up or down. Does it make sense now, Liseko?
Yes, sir. I think
Good,
I'll
good.
be able to study more on this information.
Yeah, so what you need to do, get past exam papers and then try to see how they calculate the kinetic friction. You will see that formula, there, I think I'm able to make a statement to say that formula, it remains the same. You just need to be careful of noting all the up and down forces, and then based on the up and down forces, you will make N the subject of the formula. And then whatever that you have as the subject of the formula, you substitute it into this formula. Because sometimes, Liseko, you will be given mu, but not given N. So you need to work out N based on the available up and down forces. Then that's when you will calculate the frictional force.
Okay, sir.
So just make sure, honorable members, to watch this lesson again. Watch this lesson again. Otherwise, you can still check on other previous question how we have done it. I've also done some private lessons on this. The recordings are also available, so you've got enough information to check. Any questions, honorable members? Were you guys listening? Did you understand? Asnati, Bukamso, Ethan, Helri, Lavella, Anosweld, Nladi, Numfu, Nuntati, Rufin, and Serene. Did you guys understand? Serene is understood.
Yes, sir.
Okay. Okay. Looks like that was clear. Yes. Okay. Then it's fine. So guys, for today, we will just leave it here. And from my side, I would like to say Aswonge, Aswonge, Aswonge.